So welcome today, guys. We're still working on 4.02. We will be a couple of days. I want to do lots of examples tomorrow, but I want to give you the basic identities that we need to know for today. We're going to focus on the sum, difference, double, and half angle identities. This is what they look like. So we're going to start off with the sum and difference identities, and there are 6 of them, and they're all listed here. My suggestion is you write them in your set of notes of identities so that you always have them available. You can always look at them, and over time begin to memorize them. Now, what's going on here? Let's just look at the first one right now. Basically, we take the sine and we end up adding 2 angles together, like 10 degrees and 25 degrees, or pi over 6 and pi over 2. So all we're doing is just adding 2 angles together. And in a sense, instead of actually having to add the angles together, this gives us a formula where we can use sines and cosines, sine alpha, cosine beta, plus cosine alpha, sine beta, to actually get the solution. And I'll show you some applications of this in a moment. Now, all the others are done very similarly. All right? Now, I had to memorize these when I was young and taking them in school. And so, in fact, one of our quizzes was we had to write down all the fundamental identities, all 30-some that we were given at the time. And these were 6 of them. These were the hard 6 to memorize, I felt like. And so how'd I remember them? Well, the sine of alpha plus beta is equal to different functions, same sign. So sine alpha cosine beta plus cosine alpha sine beta. Sine alpha minus beta works exactly the same way. Different function, same sign. Cosine alpha plus beta is same function, opposite sign or different sign. Okay? So you'd get cosine alpha cosine beta minus sine alpha sine beta for cosine alpha plus beta. And then the tangents, I would remember, I knew they were just tangent functions, but I remember if it was plus, you'd have add over subtract, and if it was subtract, you'd have subtract over add. And that's kind of how I started out trying to memorize them so I could remember them and look them up. So I didn't always have to pull out the sheet of paper to do the problems. Now, what are the key right now? There are 2 things that I would like to do with these. 2 things I would like to do with these identities. Okay? Number 1, I'd like to show you example problems of where these identities are helpful. Okay? Example problems. All right? Number 2, I'd like to show you a proof of how at least one of them comes about. So we'll pick one of these identities, and I'll show you how you can get it from our normal trig situation and where it comes from. So this proof shows us where these came from and why they were somewhat important. Okay? So we're going to first go off on the examples, and then we'll have the proof at the end. Alrighty, let's go to the next page. So it turns out 360 degrees, or 2 pi, 360 degrees can be divided easily by 12, just like we did by 2 and by 4 and so forth, you know, and we ended up eventually with, 180 degrees, 90 degrees, 60 degrees, and so forth. So One of the things you can do is you can divide 360 by 12 and 24 fairly easily. All right. And what this means is you can essentially get angles that are multiples of 15 degrees. So in other words, our special angles are 0, 30, 45, 60, and 90. But if you can find an easy way to calculate 15 degrees, or multiples of 15 degrees, like 75 degrees, then you can do these problems. So here's a quick example. So the sine of 5 pi over 12. Well, how do you get 5 pi over 12? Well, if you think about it, it's like a 2 pi over 12 plus a 3 pi over 12. Oh, wait a second. That's pi over 6 plus pi over 4. So what you're looking for are combinations, either addition or by subtraction, that are combinations of special angles. So this can be rewritten as the sine of pi over 6 plus pi over 4. And now, since we know the sum formula, we can rewrite this in terms of special angles. So it becomes the sine of pi over 6, the cosine of pi over 4, plus the sine of pi over 4 times the cosine of pi over 6. And now we can just calculate these quite easily. This is 1/2. This square root of 2 over 2 plus square root of 2 over 2 times the cosine of pi over 6 is square root of 3 over 2. And so if we multiply that out, we get square root of 2 over 4 plus the square root of 6 over 4, which is equal to the square root of 2 plus the square root of 6 over 4. And this is the exact value of sine of 5 pi over 12, which is actually 75 degrees as well. Okay? So let's do the next problem. So we'll circle it up here. Tangent of 15 degrees. And so if I'm going to do that, I'm going to say, okay, 15 degrees, how can I get 15 degrees from special angles? Well, I can do 60 minus 45 degrees, or I can do 45 degrees minus 30 degrees. So any of those are going to work out. And there'll be another way to do it here in the future in just a moment. So I'm going to do it as the tangent of 45 minus 30 degrees. So what's that equal to? Well, I know the difference formula for tangent. It's tangent 45 degrees minus tangent 30 degrees, same sign in the numerator, opposite side in the denominator, 1 plus tangent 45 times tangent 30. All right, and we can go ahead and work that out the rest of the way. Tangent of 45 degrees is 1, minus the tangent of 30 is 1 over the square root of 3 divided by 1 plus tangent of 45 is 1 times 1 over the square root of 3. So what we end up with is 1 minus 1 over square root of 3 and 1 plus 1 over square root of 3. This is a complex fraction, so we multiply the numerator by the square root of 3 and the denominator by the square root of 3. And so to clear the fractions. So that gives me, and that's just algebra. So do you remember doing these in algebra where you had to get rid of and simplify it to just one expression? Well, here's an application. It shows up. This is why you did this problem in algebra. This brings up the fact everything you do in math, you end up using in math. The first application of math is always more math, first off, just so you know. So I rewrote it like this so I can show you the distributive properties a little easier. So we'll do that, and we get the square root of 3 minus 1 over the square root of 3 plus 1. And then we want to rationalize the denominator. Remember, you can't have a square root in the denominator. So in my mind, this is a good enough answer, but I imagine online for K-12, you got to get rid of that radical. So we multiply by the conjugate, square root of 3 minus 1, conjugate of the denominator. And so this is a plus b times a minus b. So it's a difference of squares. And so we can go ahead and multiply that out. And the numerator will get 3 minus 2 square root of 3 plus 1. Go ahead and FOIL this out and see if that's not what you get. Okay. And then in the denominator, we'll get 3 minus 1. And so we end up with 4 minus 2 square root of 3 over 2. Oh, and the 4 minus 2, those 4 and the 2 are both even. So we can factor a 2 out. So I got just a little more to do here. So factor the 2, and you get 2 minus the square root of 3 over 2. The 2's cancel, and you end up with 2 minus the square root of 3. And so the tangent of 15 degrees is equal to 2 minus square root of 3. Now I want you to notice, here's a little arithmetic to figure out what angles to use. Here's the trig substitution. Then where we change the identity. And then here's the our table from chapter 1 where we make the substitutions. Everything after this point is simplifying radicals and fractions. Okay? And that's all algebra 1 and algebra 2. Okay? So this is chapter 1 in trig, writing this down. This is chapter 1. And this is our new section, writing this down. So that's our chapter 3. Okay? And that's where this comes from. Now, if you had done 60 minus 45 degrees, you would have got the same answer. You should check it and see if you do. Alrighty? Let's go to the next problem type. So the next problem type you might see would be a problem that looks like this, where you have two angles, and it's actually one of the sum or difference formulas. And I recognize this one as cosine alpha plus beta, because remember, they're the same function but different signs. So this is cosine alpha plus beta. But what is alpha? In this problem, alpha equals 70 and beta equals 20 degrees. So we really have the cosine of 70 plus 20, which is the cosine of 90 degrees. And the cosine of 90 degrees is 0. Done. This is the exact value. Okay? Now, you can do this with radians as well. I see one here. They have like the cosine of pi over 18. The sine of 5 pi over 18 plus the cosine of 5 pi over 18 sine of pi over 18. So these are different functions, same sign. So this is really the sine of pi over 18 plus 5 pi over 18, which is the sine of 6 pi over 18, which is the sine of pi over 3. And the sine of pi over 3 is square root of 3 over 2. Exact value. Okay? So the question here says, find the exact value of this expression. All right? So let's go to page 4 and do the next problem. Okay, so this next kind of problem that you have with these sum or differences is a little bit different. So let me explain what you're given. This is sort of the given. All right? And what you are given is that sine of alpha is 5/13. And then they tell you that alpha is between negative 3 pi over 2 and negative pi. So what does that mean? Well, if you go to negative 3 pi over 2 and then to negative pi, that means the angle is in quadrant 2. So this means quadrant 2. Okay? And then cosine beta from 0 to pi over 2 for beta, that means that is quadrant 1. Okay? So in other words, we've got an angle from quadrant 1, beta, and an angle that we go all the way around to, that's alpha, and we're going to add those two angles together. Now, of course, it'll end up being like we're sort of subtracting beta from this angle, but then the question is what's going to be like the sine of alpha minus beta, or the cosine of beta minus alpha. So we're going to have all kinds of things that happen here. And so we want to be able to figure that out. So a good problem would be something like this. Find the cosine of alpha minus beta. So they give you the information up here, and this is what we kind of understand. These are really telling us what quadrant they're in, and I think in your lessons they just tell you the quadrant. They don't write it out like this, but I'm grabbing this from another book, and so I thought I'd explain that to you. All right, so we want to find the cosine of alpha minus beta, okay? Now, I already know what this is. This is the cosine of alpha, the cosine of beta, plus the sine of alpha, sine of beta, okay? So I already know that because I know the difference formula for cosine. But this shows me something. I know the sine of alpha and I know the cosine of beta, but I don't know the sine of beta yet or the cosine of alpha. So I need to find those things. So what I have to do is I have to think about this diagram where I thought where the angles were. So what I know, all right, is that alpha is in quadrant 2, okay? Between negative pi and negative 3 pi over 2. It's in that quadrant, okay? Since it's in that quadrant, okay, the reference angle is going to be the reference angle for alpha, okay? And since it's in quadrant 2, we know sine is opposite over the hypotenuse. So we know this is 5 and this is 13. We can then use the Pythagorean theorem to help us find the x value. So we go 5 squared plus x squared equals 13 squared. That gives us x squared equals 144. And that gives us x equals plus or minus 12. Now, which one is it? It's minus 12 in this case because we are in the second quadrant. Okay? So x equals negative 12. All right? It's not really a distance now. We're just, we're giving links, or not links, but we're indicating the value of the ordered pair. Remember when we did the unit circle? We're finding values of ordered pairs in a circle with a radius of 13. That's what we're doing here. Okay? So what does this tell me? This tells me that cosine of alpha is equal to negative 12 over 13. Okay? Now I'm going to draw the other angle. The other angle was in the first quadrant. Okay? It was cosine, so this is angle, reference angle for angle beta. So cosine of beta was 1/2, so that means adjacent over hypotenuse. And so we can do that Pythagorean theorem, 1 squared plus y squared equals 2 squared. So y squared equals 3. So y equals plus or minus square root of 3. And the correct one here is positive square root of 3, y, because it's in the first quadrant and the x's and the y's are positive there. So now I can also write sine of beta, since I had cosine beta. And sine of beta is going to be the opposite over the hypotenuse. So square root of 3 over 2. This right here, right? This is like my scratch work. I have to do this. The problem's right here. I can finish the problem now. Cosine alpha is negative 12/13. Cosine beta is 1/2. Plus sine alpha is 5/13 times sine beta, which is square root of 3 over 2. All right? And we can proceed forward at that point. Just got to multiply, get a common denominator. So we get over 26, negative 12, plus 5 square root of 3 over 26. So this is negative 12 plus 5 square root of 3 all over 26 because they have a common denominator. So that is the exact value of cosine alpha minus beta. Now, you can just punch this on your calculator. You can do all this on a calculator and get a decimal answer that'll equal this. But that's not how you're supposed to do it. You're supposed to find it exactly. And so nobody wants you to do it with a calculator. No math teacher, no trig class. They want you to do it all like this. However, I do want you to check your answer with a calculator. So how would you do that? Well, the way you would do it is you want to find what the angles are. Now, I'd just say about that last problem, if they had wanted tangent alpha or tangent beta, so for instance, they wanted us to find tangent alpha plus beta, which is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Well, from those triangles that we had, negative 12, 5, 13, and to 1 square root of 3. And this was beta, and this was alpha from the triangles we had before. Well, we could find tangent alpha. Tangent alpha would be opposite over adjacent, so negative 5/12. And tangent beta would be square root of 3 over 1, or square root of 3. And so we could then substitute up here for tangent alpha and tangent beta and solve for the tangent. So no matter what one they give you, by doing the right triangle work, paying attention to the correct quadrant where things are at, you're going to be able to then find the things that you need. And this would be if they told you what sine alpha and cosine beta were. And you could still do the tangent alpha, tangent betas. Okay? So let's move on to the next type of problem. So once you know the technique from the last problems that we did, you can apply that technique over and over. So here they say, suppose cosine theta equals 1/4 in quadrant 4. So we can immediately go to a quadrant 4 angle here, right here. That's theta, or the reference angle for theta. And cosine is positive in quadrant 4, and it's adjacent over the hypotenuse. We can then use the Pythagorean theorem, 4 squared equals 1 squared plus y squared, which will be 15 equals y squared, which will then give us plus or minus the square root of 15 equals y. But since we're in quadrant 4, the y value will be negative, and we can label that. And now we can do all this stuff, right? What's sine theta going to be? Well, it's going to be the opposite over the hypotenuse. So it's going to be negative square root of 15 over 4. Put that negative out there. All right. Just remember, sometimes on the computer answers, they might like you to put that negative out in front of the whole fraction and not just with the numerator or denominator. So kind of keep that in mind, even though those are all the same and equivalent. The tangent of theta is going to be the opposite side over the adjacent, so negative square root of 15 over, or just, excuse me, kind of blinked off on me there. So I must have double click something with my thumb. I did. So this will equal negative square root of 15. Okay. And then if I have to find something like sine of theta minus pi over 6, then I use sine theta cosine pi over 6, same sign, sine pi over 6, cosine theta. All right. And I fill those in. Well, I found the sine of theta. It's negative square root of 15 over 4. The cosine of pi over 6 I can get from my table. That's the square root of 3 over 2. All right. The sine of pi over 6 is 1/2. And the cosine of theta I was given, it's 1/4. So this will be minus 1/8. And this over here will be negative square root of 45 over 8. And then you can simplify that. 45 is 9 times 5. So it'll be negative 3 square root of 5 minus 1 all over 8. And there you go. So using the same technique. Now remember, we did this on inverse functions. And now we're doing it on sum functions. Okay? The only other thing I see would be this problem. So we're going to do one other problem. Okay, you just saw me write that one out. Fortunately, I wrote it quickly, so it's only 30 seconds of silence. But anyway, this is a cosine of an alpha plus beta, all right? So where alpha is equal to the inverse tangent of 4/3, and beta is equal to the inverse cosine of 5/13. So now let's see what you do with that problem. What you want to do then is we're going to rewrite it as cosine alpha cosine beta minus sine alpha sine beta. All right? And then I'm going to want to substitute. But what you notice is that alpha, I know what alpha is, and I know what beta is, so I can plug those in for each one of this. So here's what this will look like. It'll look like the cosine of inverse tangent 4/3 cosine inverse cosine of 5/13 minus sine inverse tangent of 4/3 and then times the sine inverse cosine of 5/13. So we've done these problems before. We did these problems earlier in another section on inverse functions in the last chapter. So we know how to figure these out. It's very similar. Since this is the inverse tangent of 4/3, this is telling me the ratio for the tangent of the angle is 4/3. Because I could solve this equation and say tangent alpha equals 4/3. So it's telling me the ratio. All right? So I just need to draw that ratio out. 4/3. Here's the angle. All right, we'll call it alpha. And then the 4/3, it's opposite over adjacent, 4/3. And so 3 squared plus 4 squared equals 5 squared. That's a Pythagorean triple, so I know that one. So the hypotenuse is 5. And then this is basically saying I want the cosine of this angle. All right? Well, the cosine is adjacent over hypotenuse. So it's 3/5. All right? So that's that triangle. All right? Now, and just so you know, I've got another triangle to do for this one. The inverse cosine of 5/13. So that's telling me that cosine of beta is 5/13, that the ratio is 5/13. So let's make that ratio. All right? So this beta, cosine is adjacent over hypotenuse, so that would give us 5/13. And if we do the Pythagorean theorem again, we're going to get 12. 5 squared plus y squared equals 13 squared, y squared equals 144, and we get 12 there. Okay? And so now I want the cosine of the inverse cosine. And by the way, that's 5/13. So that makes sense. So now I come to the other side, and I want the sine of the inverse tangent of 4/3. Well, I can use the same triangle. That's just 4/5 opposite over hypotenuse. And I want the sine of the inverse cosine of 5/13, and that's opposite over hypotenuse 12/13. And so all I need to do is multiply these out, collect some like terms. 15 over 65 minus 48 over 65 is equal to a negative 33 over 65. And there's our solution. Okay, now they're asking for exact answers on these. Again, notice this will be a reminder of how we did the inverse functions, but notice we're drawing triangles when we take a trig of an inverse trig. So we draw, because we know the ratio, we can draw the triangle and figure it out. Now, the one thing you need to remember is if this had been like the inverse cosine in negative 5/13, you have to remember that's going to be a quadrant 2 angle, because inverse cosine goes from 0 to pi, and I'll have negative ratios in the second quadrant. So you got to remember quadrants in case they give you problems like that. Okay, so that's everything I have for you on the sum and difference of angles. So what we're going to do is I'm going to do the double and half angles tomorrow. And I might, I don't want to make this too long, but I'd like to talk about the proof of where do these sum and difference of angles come from. I want you to kind of see where they come from. So I may just talk about that one in class, or I'll do it in the next video, or I'll make an extra video. I'll figure out what to do, but I will show you a proof so you can go, oh, that's interesting. That's where they come from. Anyway, good luck. Enjoy the problems. We shall see you for the next video. Bye-bye.